Hello everyone! Welcome sa panibagong series natin at dito pag-uusapan natin ang integration. Sa unang video na to, we will be discussing the different theorems kung paano mag-evaluate ng integrals ng algebraic functions. Without further ado, let's get this lesson started. Kung ang addition, ang kanyang opposite ay subtraction, tapos ang multiplication, ang opposite niya ay division, yun namang ating derivative or pagde-differentiate, ang opposite niya ay tinatawag na integration. Ang sagot sa integration ay tinatawag na integral or antiderivative. Sa notation na to, ang derivative natin is yung f of x. Kinukuhanan natin siya ng integral to identify the function na kapag dinerivative natin, ang sagot ay itong nasa loob. This is read as the indefinite integral of f of x with respect to x, which will result to f of x plus c. Yung ating small na f of x, yung kinukuhanan natin ng integral at tinatawag siyang integrand. Yung d of x ay yung with respect to x, yan yung nagsasabi kung anong variable yung sisunod ng integration. Yung f of x na ito, na sagot, ay tinatawag natin na integral or antiderivative. At yung c naman, yung tinatawag natin na arbitrary constant. Ibig sabihin kasi nito, as we recall from derivative, di ba kapag constant, pag kinuha natin siya ng derivative, nagiging zero lang naman siya. So, yung mga zero terms dito sa integrand, hindi natin sure kung anong number sila talaga originally, kaya maglalagay na lang tayo ng arbitrary constant na plus c. Meron tayong 4 theorems of integration. Una, yung ating power rule. Pangalawa ay yung integral of a constant. Next is yung constant multiple rule at yung sum and difference rule. Itong apat na to yung content ng video natin. So let's start with power rule. From the word itself, power rule, ibig sabihin nito, meron kang isang variable na walang coefficient except for 1, walang ibang denominator except for 1, tapos meron siyang exponent na n. Dapat yung n natin hindi daw equal sa negative 1. And then to get its derivative, we'll just put plus 1 beside the original exponent. And then we'll put a denominator na very similar dun sa ating bagong exponent. And then don't forget to include plus c. As we can see dito sa example number 1, meron tayong x raised to 7 as the integrand. So according to power rule, what we will do is we'll drop the integral sign, we'll drop the dx, at itong 7, kukuhanin natin, dadagdagan natin ng isa over that exact new exponent, and then plus c. And then simplify. This will be 7 plus 1, 8, as well as 8 in the denominator, plus c. Yun na yung ating integral. In the event na meron naman tayong exponent na ganito yung itsura, may exponent tapos may variable, tapos yung variable is nasa denominator, and we have 1 in the numerator, what we can do is we can transfer this denominator pataas dahil gagamitin natin yung tinatawag na negative exponents. So according to negative exponents, if the expression is found in the denominator, we can write it in the numerator, but the exponent should be changed into negative. And then we can apply the power rule. So, set up the fraction. We have n, negative 12 plus 1, negative 12 plus 1, plus c. Every time na tinatanggal na natin yung pagsulat ng integral sign, ilalagay na natin dapat yung plus c. This is n raised to negative 11 over negative 11 plus c. But this time, it is not yet simplified kasi meron pa tayong negative exponent. So, what we will do is we will bring this down para mag-positive exponent siya. Tapos, meron pa rin tayong negative 11. Pero, yung negative, ilalagay natin nakapantay ng fraction bar. And then, yung numerator 1 na lang kasi wala nang naiwang term doon. So the answer is negative 1 over 11 n raised to 11 plus c. Again, this happens if we have a certain variable raised to a certain exponent and that exponent should not be negative 1. Paano naman kung number lang yung kinukuhanan natin ng integral or constant lang siya? So according to Theorem 2, if we have only one number as the integrand, what we will do is we will look for the variable na kinukuhanan ng integral, tapos idadagdag or imumultiply natin siya doon sa number na yon. For example, number 3, itong 2024. Di ba wala naman siyang variable dito? So, the integral of 2024 with respect to y is 2024. Don't forget, we are dealing with y. So, 2024y plus c. That's it. If we have pi over 2, we cannot use the first solution that we had nung example number 2, yung itinataas natin yung denominator, dahil useless naman siya dito. Wala naman kasing variable x dito. So, ginagawa lang natin yun kapag may variable. In this case, pi over 2 is a constant. It's a real number. So, we will just write pi over 2. This is with respect to x, so x plus c. And that is already the final answer for number 4. Next, we go to Theorem 3, kung saan pinagsasama naman niya yung number, sabi sa Theorem 3, yung ating constant multiple or yung coefficient natin ay present sa tabi ng variable x. So, paano natin siya kinukuhanan ng integral? So, according to Theorem 3, what we will do is whatever we find as the coefficient, we will somewhat factor it out, ilalabas natin siya, and then we will apply the Theorem 1. So, dito, ilalabas natin si 3. We still put the integral kasi hindi pa natin ginagamit yung first theorem. Now that we have factored it out, at naiwan na lang is p raised to 6, this meets the criteria for theorem number 1. So, we will now write p 6 plus 1, 6 plus 1. And then, dahil tinanggal na natin si integral, we put plus c. This will be 3 p raised to 7 over 7 plus c. We have to take note na itong mga fraction na nagiging sagot natin, kailangan sila ay naka-lowest term or naka-simplest form. Itong 3 at 7, wala na naman silang common factor, so we will leave it as like that. Next, for example, number 6, you may pause this video and we'll resume after 5 seconds. Tingnan natin kung may answer ka na dito sa example number 6. Dito, dahil meron tayong variable sa denominator, we can use again the laws on negative exponents, kung saan we can rewrite this as 21x raised to negative 14. Then we apply the constant multiple rule, 21 integral of x raised to negative 14 dx. Then we apply the theorem 1. So we still have 21, negative 14 plus 1, negative 14 plus 1, plus c. So this is 21 x raised to negative 13, all over negative 13. This is not yet simplified because the negative is still found in the denominator. What we should do is we write it in line with the fraction bar. And at the same time, x raised to negative 13 should be written sa denominator. Dahil negative yung kanyang exponent. So that is for example number 6. Now, sa theorem number 4, what if halo-halo naman siya? In other words, ganito siya. meron siyang maraming terms na kinukuhanan ng integral, tapos yung mga terms na yon ay separated by plus or minus. So, according to Theorem 4, what we will do is we will get their individual integrals, tapos sa dulo ay i-add or isusubtract natin sila. For example, this one. What we can do is we will get the integral of the first term and the integral of the second term. And then sa dulo, i-add natin sila. But before doing that, this should be written as x raised to 1/2. Lagi dapat na naka-exponential form para mabilis nating maa-apply yung mga theorems on differentiation. So, i-rewrite muna natin. This will be 4x to the 5th plus 6, and then this is x raised to 1/2 dx. Now that it is written as isang line lang, walang mga square root or denominator, what we can do next is apply Theorem 4. So that is the integral of 4x to the 5th dx plus the integral of 6x raised to 1/2 dx. Applying Theorem 3, we can factor out 4 and 6. So this is 4 integral of x to the 5th dx, 6 integral of x raised to 1/2 dx. And now we can apply theorem number 1. So this is 4 open parenthesis x 5 plus 1 over 5 plus 1 plus 6 x raised to 1/2 plus 1. Uy, dito tayo magkakaroon ng additional recall, no? Kung paano mag-add ng fraction. So the first quantity will be 4x raised to 6 over 6. So mamaya, ito ay ilo-lowest term natin. This is 6. X raised to 1/2 plus 1 is 3 halves. So over 3 halves plus c. We cannot consider this as the final answer kasi dahil sa unang tingin pa lang, may denominator tayo na fraction. So, kailangan natin i-simplify yan. Itong 4 over 6, pwede pa rin siyang ma-lowest term. So, let's do that. 4 over 6 are both divisible by 2. Doing that, we have 2x raised to the 6 over 3. And ito, 6 divided by 3 halves. 6 divided by 3 halves can be written as 6 times the reciprocal of 3 halves. Recall how we divide fractions. So, multiply the reciprocal of the denominator. So, that is 2/3. So, 6 times 2 is 12 over 3. 12 divided by 3 is 4. So, the coefficient for the second term is just 4. X raised to 3 halves plus c. Pwede mo pa itong gawing square root dahil naka 3 halves pa yung kanyang exponent. Pero pwede rin naman na ganyan na lang yung final answer. Ang important is correct yung mga values or yung mga numbers natin. For example number 8, please think about this for 5 seconds and then after 5 seconds magre-resume tayo. Tingnan natin kung ano dapat yung first step of solution dito sa example. So, dito sa example number 8, meron tayong denominator na k squared. But, we are lucky dahil yung denominator ay isang term lang. Recall that if we have a fraction and yung denominator natin ay isang term lang, what we can do is we can rewrite this entire given as separate fraction. Ibig sabihin, pwede natin siyang isulat as 8k to the 4th over k squared plus 9 over k squared. Again, this is only applicable if yung denominator natin ay one term lang. Kung merong naka-plus dyan or naka-minus at 2 or more terms na siya, we cannot write them separately. So now that they are written separately, we can use again the laws of exponents to simplify them before we use the theorems. So, this is 8k to the 4th divided by k squared. So, pwede nating i-subtract yung exponents niya. That is just 8k. 4 minus 2 is 2. And itong k squared naman, since hindi tayo pwedeng mag-subtract ng exponent, no, obviously, wala namang k dito sa taas, we can use the negative exponents such that this can be written as 9k to negative 2, dk. We apply this theorem for, so integral of 8k to the second power, dk, plus 9, or the integral of 9k raised to negative 2 dk. Next, we apply theorem 3. Let's factor out 8 and 9. Now we can apply theorem 1. So this is k squared plus 1, 2 plus 1. And then for 9, we have k negative 2 plus 1, negative 2 plus 1. Then don't forget plus c. This will be 8k cubed over 3. Wala na tayong pwedeng ma-lowest term sa 8 over 3. This is 9k to negative 1 over negative 1. Ito, dito tayo pwedeng mag-simplify kasi merong negative exponents. So, doing that, we have 8k cubed over 3. And then, divide na rin natin, no, itong 9 saka negative 1. That is negative 9. Tapos, yung k raised to negative 1, ibaba na natin siya. No need to write 1 here. Understood na to na may exponent na 1. So, plus. Again, this became negative 9 because we divided 9 and negative 1. 9 divided by negative 1 is negative 9. And then, all over k. Wala na tayong masisimplify pa dyan. Wala na tayong mako-combine. So, this is already the final answer. Isang tip ko sa pagkuha ng integral is i-simplify mo muna yung given, whatever given that you have here, simplify mo muna siya either by loss of exponent o kaya by FOIL method kung pwede, by division kung pwede, bago mo simulan ng theorems. Dahil it will make your solution easier kung sa simula pa lang ay sinimplify mo na yung given na polynomial bago mo kuhanan ng integral yung integrand na nasa loob. So, just make sure wag malilito sa pag-simplify at wag malilito sa mga theorems na pinresent natin dito. Sa next video, pag-uusapan natin, what if hindi na applicable itong mga theorems na to? Say, for example, meron na tayong mga naka-quantity squared, no? Yung buong integrand naka-squared, naka-cube. Paano natin yun kukuhanan ng integral?